start with you. Your interest, you say, was sparked in high school. What was it about your teachers that attracted you to science?
The Depression. We had two very good teachers, one a PhD in physics. During the Depression, when they finished, there were no jobs, so they decided to get into teaching science in high school.
The microphone.
Okay, here.
Who said that? Okay. Anyway, that is why I think we don't see too many people like that, but that's an answer to that.
So you had a PhD as a high school science teacher?
PhD in physics from the University of Minnesota.
Wow, amazing.
He knew the subject, he had a lot, he had a good way of bringing enthusiasm into it, and the one in chemistry did too. It was, so my interest, I've been curious a lot, but these people helped. That's about it.
Okay, but right after high school, you went into the Navy, is that right?
I was in high school I joined the high school while I was, did I join the high school or the Navy? It was the Navy. And this was, people today have a hard time understanding how the spirit was at that time. Every boy in high school was either enlisting or being drafted, and so it was a question of choosing what to do. And I chose program in Navy aviation. I learned a lot. It helped me in many ways later, but that's why a lot of people say, well, why didn't you have anything better to do? And people today don't realize that was it. Anyway, that explains that.
Well, Will, I'm going to turn to you for a minute and say that both your parents were teachers. And is that where you got your love of science or the direction you took in life?
I wish I could say yes, but I think I just drifted. It was fairly easy to get into science programs. And one of the last questions you mentioned was whether I would recommend it to somebody. I was okay at it, so I was lucky. But if you're going to go into science, I think you have to really look at the options now. Because we didn't. It was like joining the Navy. If you could do long division, you could get a job anywhere.
Now, before you put that down, though, so you got your undergraduate degree in Canada and another one from London University, University of London. How did that work?
I guess it worked okay. The thing that's wrong with it is that if you go to London as a young man, there are other things to do rather than academics. And I did.
Paint a picture for us of London at that time. It's a prestigious university, obviously a lot of extracurricular activities going on. Was the department, did you respond to anybody in that department?
No, but it's as you say, it was a good university, and the thing I responded to was the partying they used to have.
You're setting a fine example for the youngsters. Well, I'm going to start with you, Will, since you have the microphone, but you both ended up at Caltech. So what drew you there first, Will?
What drew me there was a guy that I knew who was a postdoc, and he was in nuclear physics, and that's why I did that. I didn't know that, the guys that had developed the H-bombs were mostly there after the war, and I didn't know that the experiment that I did for a PhD had anything to do with bombs or war or anything. And then one day, a recruiter came around from Los Alamos. That's where they designed the bombs. And we sat down and had a nice chat. And what I didn't know was my experiment was bombarding lithium and then looking to see what came off. And I didn't know at that time that they used lithium in hydrogen bombs. And so if you're interested in hydrogen bombs, you're interested in what the lithium does, because there's a lot of it. They unite the stuff with the lithium with the heavy hydrogen. And the compound is chemical. It's a lithium hydride. I never heard of it myself. But we got on this line of talk, and then he said, it came out that I was not a citizen. And the guy, that is something you have to see. I mean, he turned white and he was gone, and I suspect he didn't ever make it back to Los Alamos.
Well, if you hand that to Carl, the microphone to Carl, Carl, what drew you to Caltech?
Well, the glaciology and Bob Sharp, who was the leading glaciologist in the country at the time, and I had met him when he was on the faculty at the University of Minnesota. And Sharp was very athletic. He liked to play handball, and I was swimming at the time, and I was on the, actually, I used to be a good swimmer. And so I was on the swimming team, and we'd frequently walk over to the athletic building together, and I got to know him that way, but he was also an outstanding lecturer in general geology, and kind of person that could make anyone really interested in a piece of sandstone. And he wasn't there long before he went then to Caltech, and I learned a lot about him later. He was in this group out of the OSS during the war, which was part of they call it the Arctic Desert Tropic Information Center. They had experts like, Sharp, there was Paul Victor from France, there was Washburn and Gould, a lot of you name may not meet you. These were the top people in the game. And one of his things was teaching people survival in Arctic conditions. And I heard this after I'd known him for a while, and people pointed out that he was sort of scoffed at by some of the officers out in the Aleutians. They said, well, this is nonsense. And they said, and he was saying, this can save lives. You know, if somebody's down, how to live. Well, he says, suppose we take you over here to this island. This is Agatu Island out in the, way out in the Aleutians. Suppose I just drop you off there and leave you for a week. You think you could survive? I said, sure. So they came back for him. A week later, he not only had thrived, he had made a geologic map of the island. It was public. And that was just typical.
Yeah.
And he worked first in Alaska here and followed up in other things. But he was just a good mentor for me at the time. And I didn't get into glaciology initially. I was in general, like the work I did in northern Alaska. That was just sheer delight for a young person just finishing a bachelor's degree, come out and have the opportunity to work with probably the finest group of geologists ever put together. The group, they called it the Navy Oil Unit, because Navy Oil Reserve number 4, the biggest of all their reserves, set aside by President Harding in 1923. The Navy decided after Pearl Harbor, they want to see what do they have in these reserves. And they knew there was certain oil, but they contracted the USGS to set up a special unit and start exploration. And they had, it was a profound impact on Alaska because the runway, aircraft runways at Barrow, Umiat, and Barter Island were all built by that group. The Seabees, the Navy Seabees, the construction battalion. They did all the construction. Then there were flights, and people worked in the field under conditions people don't think of today. Very interesting. And that was one of the most delightful field seasons I've had because, among other things, I didn't have to plan it. Irv Tallier had planned it and got the logistics and had airdrops to space stuff out in places. We went out, pulled things off ice and lakes to the shore before the melting happened so we could get at it. And I was impressed with the organization, and all I had to do was go along, hike, climb. I wore out 2 pairs of shoe packs, and it was a fascinating summer. I learned about Alaskan mosquitoes. And anyway, that is what started me when I went back to the university. I was going into graduate school, and there was this group called the Snow, Ice, and Permafrost Research Establishment. The initials were SIPRE. It turned later into the group that Matthew Sturm and others here worked with, and so did I, called Cold Regions Research and Engineering Lab. And the first one, they were bound to change the name because SIPRE, CIPRE, the GIs came up with their own interpretation. Stupid individuals performing ridiculous experiments. And that's how that got going. So they changed the name and moved. But I never regretted going with that outfit. It's curiously, in 1950, when I came back, I was starting grad school, there were some recruiters, like what Will ran into, but they were looking for young people to get involved. And a place called Geophysical Services Incorporated, and people have probably heard of it here, GSI. They were looking, and I went down to Texas to an interview, and they offered me a salary that was fantastic, and this, at the same time, CIPRE was willing to take on people. I'd been working as a research assistant, so I wondered about full-time there. They came up with an offer that was exactly 1/2 of the salary, and I jumped at it because they offered an opportunity to get into the Arctic. There was potential for logistics in the Arctic. I had always wanted to be in the Arctic, and I've never regretted that decision. The finances were totally irrelevant from the point of view of the experience.
Well, hand that over to Will, because I want to ask a question, something you raised. There's this, often when you read about the North, there are writers who will talk about the idea of the North, sort of this almost romantic appeal. There's something that draws people towards it. And I want to ask both of you, did you say you always wanted to go? How about you, Will, north? Was that anything like an allure for you?
No, in fact, the truth is that Carl recruited me to come north. And he came to Pasadena, just as an aside, he came to Pasadena where I was living, and he didn't recruit me, he recruited my wife. And she's always admired him for that. But I got interested in the North through mountaineering, mainly. And there wasn't much, the projects I was in, the climbing projects, there wasn't much science involved. But I thought this was a good deal, especially after Carl's visit. And that's how. Carl's to blame.
As so often
I
is.
should explain the reason. If I didn't think I had recruited Ann, but I liked Ann, obviously, so did Will. And but I figured Will was in the bag. One of the problems we've had here when we bring people in is the wife gets upset after a while and doesn't want to stay here, and so they all leave. Well, I knew Will was going to be happy here, and I wanted to just make sure that Ann would be happy coming here too. And I think she's been happy here. She always smiles. But that's why.
Well, yeah, you talked about that summer where you wore out 2 shoe packs. You first set eyes on the university during that time, didn't you?
That's right. In the late 40s and 50, to get to the university, it was a gravel road, college road. It wound around more than it does now. And it was a terribly dusty ride. And the gold dredges are still operating out here at Esther. So we went around and I talked to the people at the university. The Geophysical Institute was pretty nearly finished. The Brooks building was the pride and joy of the place. And it looked like an interesting spot, but people told me, this is academic Siberia. You don't even give it another thought. Well, when I was in grad school, and I was talking to Will and found the Geophysical Institute was really operating, it looked like a good base. And so that's why we came here. And Ruth said, well, we'll give it a try for, say, 5 years, maybe 10 years. That was, well, over 55, 60 years ago.
Yeah.
So she likes it too.
Talk about meeting Neil in grad school, Neil Davis.
Well, there are several people from the University of Alaska there. One was Pierre St. Amand. He's the one who discovered, named, and fought for the identification of the Denali Fault. And Neil had been here working, and he's the first one that got a bachelor's degree in geophysics at the university. So he was going to grad school. He went to Caltech and spent, I think it was almost 2 years, but he finished a master's there. And one of the things that Neil and Rosemary here founded down there was Doug Davis. They had Patsy, the oldest daughter, but Doug was born in Pasadena. A year later, Sonia, our daughter, was born in Pasadena, and they finally, now they're married, so it takes them.
Do you think Pasadena had anything to do with it?
I don't know. I think, but Will, or Neil was a great storyteller. Will is too. But, and incidentally, getting Will here is probably the only good decision I've made since I've been here, or one of the best, because I made a lot of mistakes, and I kind of cover them all up with this.
Well, talk to me about your Greenland studies, because I understand that the father of plate tectonics also studied there, Alfred Wegener.
Yeah, Alfred Wegener was a meteorologist and a broad scientist, and he saw the fits of the continents, but more than that, he saw the fits of the continental shelves. And people in South America, or South Africa, had noticed their stratigraphy was the same as what it was in South America. And as one of the people I heard one time give an outstanding lecture, he said, we walked to the edge, there's no mountain break, the rocks just stop. We look out over the ocean, we figure it must be somewhere out there. They go to Australia, down there in Argentina, and there they are, the same strata. So there was lots of things besides just the fit of the continents. Wegener was so certain of continental drift that his first expedition, or one, not the first, but the expedition he did with J.P. Koch from Denmark, who was an astronomer, was to set up points in Greenland, northeast Greenland, and in Norway, so they could measure the rate of motion. They were not arguing whether it moved. They wanted to know how fast they were separating. And he was years ahead of himself. And of course, that isn't always appreciated among your colleagues, but that reason I got in there, right now I think it's time to hear from Will.
It's like the story so far. We'll come back to that. We'll come back to Greenland. Well, Will, I'm going to ask you about your work on glaciers, and I understand you entered it through the technical side with camera work, and talk a little bit about that.
Well, okay. I didn't get my job. I got it at Caltech, a postdoc. It's great. It's a great deal to get somebody to pay you while you're learning something. So that was the deal at Caltech. but I didn't know anything about geology or glaciers. And what I did know was machine shop practice. And so I built these and Barclay Cam, for whom I worked, had his budget cut, and he didn't have money for machine shop time to make these cameras, so I made them. And that's how I got started, was making Warhol cameras. And then, of course, there are other people who were involved, and there's a whole technical difficulty in getting boreholes to the bed of the glacier, and there's debris down there. We were trying to find out how much of the glacier motion is due to basal motion, sliding over the bed, over bedrock or debris, whatever is down there. And I never saw any bedrock in several years of looking. I always saw rocks and crap down there rolling and tumbling.
And which glaciers were these? And
this was mainly Blue Glacier, and there was a guy from, we were involved in something else, the Black Rapids Glacier down here. Blue Glacier's in the Olympic Peninsula of Washington. And we were doing a project on Black Rapids Glacier, and there was a chap from JPL, Caltex JPL, who came out and did the same thing. And he saw about the same thing too. A lot of the motion there is not in the ice, it's in the stuff that underlies the ice.
I'm going to let you hold on to this, but this is a question for both of you, since you've done so much important work on glaciers. Before global climate change, we never, I don't think many of us gave glaciers a second thought.
Mm-hmm.
What was glaciology like when you started out? And paint for us a picture, if you will, what research was like back then and what you were trying to look for, as you mentioned, the movement and the...
I think maybe it was mapping and things like that in the old days, but Barclay Cam, for whom I worked, was a universal type. And he was interested in the mechanics, really nailing down the mechanics. And that's one of the biggest questions, how much is the ice actually deforming and how much is due to sliding and so forth. And no one had worried about that before. And I think people that, glacial geologists who work in the Midwest have an idea, because they've looked at so many deposits, they have a better idea than more quantitative types like me had. But they weren't doing anything in boreholes to look at real life going on beneath their very eyes. But it's not easy. We had all kinds of problems and failures, and sometimes we couldn't reach the bed, or ran into a rock or something. It's tricky. Did I answer your question?
I think so, but I talk about one of those terms about glaciers when they surge. And I always thought that was a bit oxymoronic in the sense that they don't look like they can surge at all, it's sort of...
I know.
So describe that a little bit, would you?
Well, Black Rapids is close to home, and lots of people have driven by it. It surged in 1936, the year I was born. Jesus had the Star of Bethlehem. And so and I guess there were lots of people that worked on it, and I guess right now, Martin Frufer here can correct me, is about half of the surface motion. If you walk up Black Rapids Glacier, it's hard to get there. You have to cross the Delta River. About half of it is sliding on the bed in the lower half of the glacier, and about half is deformation of the ice. And the speed during these surges it can be 50 meters a day. I've seen 50 meters a day, so they really do something.
Yeah.
And there's probably a continuum. There's probably a whole bunch of glaciers in between that just have seasonal variations in flow and so on. But when you see a real surge, you know it. You can't walk on the glacier because it's all crevassed and so on and so on. Keith Eckelmeyer worked on the Black Rapids Glacier too. Lots of people have worked on it. Troy Payway in the old days worked on it.
Well, hand it over to Carl. Carl, we still have to get back to Greenland at some point, but talk about your work with glaciers. And then if you'll both kind of reflect, you started it, Will, but I know it's a team enterprise and there are a lot of researchers and people who help work with you. And so if you reflect a little bit about that.
There you go, Carl. Sock it to him.
Well, I think one of the problems that people have with glaciers, if you have a long profile, let's say this line, if you can remember that line I just drew, that's the surface of a glacier from the top down. Now, there's constant accumulation up here, it's building up, and there's constant melting down here. This would build forever, except that the ice is flowing and sliding, and so it transports the ice from the top to the bottom. If it's in equilibrium, and ideal glacier that I just drew, an equilibrium doesn't exist, but pretend it does, then the amount of addition here would equal the amount of subtraction. So it would, you look at it, it would look like it's not changing. But Bob Sharp had a good explanation of glacier motion. Said if it's in equilibrium, it's like that. But if you get more in, then it'll start advancing at the tip. And if it retreats, it'll retreat. And so he said he was teaching this to people in Los Angeles, kids that grew up in LA. So how are you going to teach them about glacier? He said, well, I compared it to a car lot. He said, take a used car lot. You got one guy buying cars, and they're adding them into the place, and you got guys out here selling them. If the guys buy too many cars, then pretty soon they haven't got enough parking space, and they start spreading out in the sidewalk and the street. And that's so that car lot is advancing. The same thing with a glacier does. And then if your guy sells more than they can buy, it starts retreating. And he said he found that Los Angeles kids could understand that. And that's why he anyway, one of the problems in the high parts of a glacier is really a sedimentary rock. You add one layer of snow, you add another one. It goes through temperature changes. Maybe if it's down where there's melting, you get some melting and maybe some little bits of ice forming in it. And if you're up high enough, there's no melting. But you can still find annual units just because of the temperature cycle in it. So one of the questions that you want to know, for example, in Greenland, the question was for a long time, is this just a relic of the old glaciers that covered all of North America down as far as Nebraska and Illinois, and in Europe, the Scandinavian ice sheet? Is Greenland just a relic of that? And so the question was that, or is it in equilibrium with present-day climate? And that was one of the questions. So you want to know how much is being added, how much is being lost at the ends, and look for a mass balance. And I got involved in that, but the reason that I went there in the first place, this organization I mentioned, Snow, Ice, and Permafrost, SIPRI, stupid individuals performing ridiculous. Anyway, that group was in the Corps of Engineers. Now, the Corps of Engineers is not noted for doing research. It's pretty much building this and that. And someone once said that every little boy and a lot of little girls like to go out in the spring and dam up streams, make up little dams here and there and let the water flow. Most people outgrow that, but the ones that don't join the Corps of Engineers. and they end up wanting to build dams and things like that. So the idea that they were going to go in and do research, never mentioned it. I mean, that never crossed their mind. But Bader, the man who started this research lab, was a real genius at dealing with the military and with the government. And he pointed out that the troubles they had, like a lot of the troubles building the Alaska Highway with the ice formations and freezing and the glaciers they'd run into, they needed to know not just dealing with this problem or that, but they needed fundamental information. So this lab was set up to do very fundamental research on snow and ice. Well, the Air Force knew that they had this kind of lab, and they wanted to build an airstrip, an air base up at Thule, Greenland. This is at 78 degrees north, off on the northwest part of Greenland. And that's the place that Peary had used Mount Dundas there for a base for going on up to his polar efforts. But they were going to build this base there, and they had just started it. And the question then was, how do we defend this thing? There were no fighter planes, there were no guns at the place, and mind you, this was during the Cold War. Joe Stalin died the second year that I was there, and that was interesting, but there are all kinds of stories about how the Russians knew about what they were doing in building the airstrip. How they would tell on the radio, they'd say, there's a flight coming in from Westover Air Force Base. It just stopped at Thunderstrom Shore to pick up things. Now it's heading into Thule, and it'll be late getting there. But on board, there's a man named Sven Olsen, and I want you to tell him congratulations, his wife just had a baby when they land. The Russians would broadcast stuff like that. And they'd land, and sure enough, I mean, they spooked people because they seemed to know a lot about what was going on. They called it Blue Jay. It was not the Thule was secret, it wasn't a name. So they'd say, well, you folks at Thule, oh, excuse us, we know you want to call it Blue Jay. And it was funny. So the question, the Air Force was wondering, well, now if we get this base, we're going to build this big base, and how do we protect it? Well, one idea was let's put radar stations out on the ice cap. So they said, we better get a hold of these guys that are experts in snow and ice to come up here and tell us how to do it. Well, we figured that we needed three things to know. One was, is there any melting at the site? If there is, you've got problems. So we want to be in a dry area. The other was what's the rate of accumulation? Because if you build a building, and they built them like this in regular tunnel or big conduit buildings were going to be built in. But when you put the building in there, some people say it sinks. It doesn't sink if you build it right. What happens is it's getting buried. So the question is, what the rate of accumulation is going to tell you how fast it's being buried. The temperature is important because you want to make sure you're not going to get too much trouble with melting. Well, that's the kind of questions they wanted us to answer. And 10 meters below the surface, the temperature variations just go down to essentially no variation. So we were trying to measure temperature 10 meters deep at places. We would fly out to these sites. And I was very fortunate because Bader, the head of the lab, and I were the only two guys that went. And Bader had been there before once, and so he wanted me to come along because I was big and strong and could dig pits. And so we did some of that. But that's what started us, is trying, and then once we started to see the complications there, I wanted to follow up on this, and they thought it was a good idea to follow up. And then it grew into repeated work for 4 consecutive years, and I got a pretty good feel for things. But the reason we could do that really was military support that I had, although I had been in the Navy, I had to cope with a whole new thing, Army and Air Force and different groups in the Army that were fighting with each other. And it's almost, it'd make an interesting comedy story to write up some of the stuff that happened. But that support was something that was infinite compared to anything I've ever had before or since. It was just enormous. If you needed something, like we needed airdrops. We had the last trek I did was 2,000 kilometers. We went into the center of the ice sheet from Thule, down the backbone that took 10, 11,000 feet, and then back out the west. It took 120 days, 6 men, We got 4 weasels, but we were able to build the weasels the way we wanted to. We could, I told them after my experience, didn't want to do it unless I could hire all of my own people, so we'd know. So I had a mechanic who had a degree in mechanical engineering from Northwestern. He was a race car driver too. He also was an expert on Studebaker. These weasels have Studebaker engines. And he then got a master's degree there doing drawbar pull tests. I'd done some of this in Labrador and Northern Ontario. Thought, well, this would be great to do this sort of testing. And he was willing to do this kind of testing, and that ended up with a master's degree. So there's your mechanic, instead of a guy who's forced to be there and the Army drafted in there. The radio man had 2 radios himself, the same as the one that we had, or he had a radio like the 2 that we carried with us. The navigator was an astronomer, a friend of George Wallerstein, an astronomer from Caltech, and he did several research papers. So in other words, we built a group that was doing their own thing. They had some interests, and it made a lot of difference. But the reason we could do all this is the money associated with the military. And during the Cold War, they literally could do anything we wanted. We planned this trip. We had 4 airdrops scheduled about a month apart on the ice sheet. That's the only, the 6 of us were isolated from everybody for this long period. The airdrops I had to schedule as much as 6 months, 8 months ahead to roughly where we'd be. And we fixed the airdrops. They were sitting on a tarmac at Thule. This bunch goes in this aircraft at this time, and then another airdrop. That kind of planning and that kind of money involved, like the airdrops were made by aircraft that flew from Texas, troop carrier wing, all the way from Texas to Thule, Greenland, loaded up the stuff, came out on the ice sheet, found us, dropped, and then went back. Now, we didn't exchange, I never saw a nickel exchange. There was never a discussion of money. All there was the authority. If you had the authority to do this, and with that backing, you did it.
Well, you
And
probably
that's
have,
totally different, because today, people, actually, you'd be surprised, but people think about money a lot in research.
go figure.
Yeah.
Well, I want to ask, if you'll hand that over to Will.
Thanks, Bill.
Talking about the arduous quality of field work, talk a little bit about helicopter rides and how successful they are on occasion, or not so much.
I'm only, I guess, 9 years younger than Carl, but things changed. And we had to pay for our logistics, whatever. And it was, in fact, it got so bad, we never had enough money, that I got to calculating how much it cost for the rotor to go around once. And then I'm not a fan of helicopters. It's amazing what they can do, but the pilots think they can do even more. And I've been in several crashes. I was thinking of 2, but which totally destroyed the helicopter. But Matthew Sturm here reminded me of another one. This 1-inch electrical conduit, I stuck a piece of that in the rotor of one other one, destroyed the blade. So I guess 3. But
You know, for some people, one would be enough.
yeah, right, I agree. Too much.
So describe a little bit how you survived those.
Luck.
Luck?
Yeah, luck. One of them was in the variegated glacier near Yakutat. It was on a kind of a peaky ridge. And I knew he was going to crash. And I said, well, we can't see anything. It's white nothing down there. Let's go by and just throw something out. Anything you've got. And he said, oh, I can make it. And then crash, and the thing was upside down. And the rotor is dug into the snow, and it didn't fall off the edge. That was the problem. But there was one guy out on the glacier, which was surging, so it was impassable, and they got him okay. And then I couldn't believe it. The weather came in. I mean, it really came in. Couldn't see anything. And then be damned if I didn't hear a helicopter, another helicopter coming in. Those crazy buggers, they're coming in to get us. There's nothing wrong with us with dislocated shoulder, stuff like that. And pretty soon we talked this guy in. I mean, we couldn't see couldn't see him until he got there. I thought, I'm not getting in this thing. This is crazy. But then I started thinking, well, if he makes it out and I'm not aboard, I'm in big trouble. So we made it out. Another time, I think it was in the Alaska range, it went kind of a pitch pole. That's a sailing term. The helicopter lost orientation, and he dug in the nose, and the helicopter went end over end, and that really destroyed it. We couldn't find it. Couldn't find the engine, for example. Finally found it in the baggage compartment, and the rotors, the shaft, I guess I call it the mast, that was driving the rotor was broken off. There's about this much, and there was a piece of rotor about this long, and the mast lying way off in the snow, somewhere. Yeah, that was enough. But that's the kind of thing that we really couldn't have done what we did without getting around without a helicopter. Or we use snow machines too, but there's some places you can't get to in a reasonable length of time, and you have to engage one of these machines.
Well, hang on for a second. I mean, from both of you, I get this, I guess it's both the allure and the challenges of field work up here in the north. And talk a little bit about putting together, the logistics of putting together these things, because as Carl mentioned, in Greenland, unless you have a Cold War going and unlimited funds from the armed services, they're pricey and things can go wrong very quickly.
Yeah, things are different. I'm intermediate between Carl and the present situation, I guess. But there's a logistics outfit that has representatives in Alaska, and they arrange the helicopter time. If there was a time when I knew every helicopter in Alaska and how much it cost every time the rotor went around. But now I don't. I don't do any field work, but I think people don't worry about that detail. They just say we need an hour of helicopter time or 2 hours. We had one of those big, Matthew Sturm arranged it. We had one of these big Chinook helicopters one time on Black Rapids Glacier. And I was joking with them about how many loads it would take in this huge helicopter to fly everything up there. And they said, well, do you want the truck? They're referring to the Geophysical Institute stake bid truck. It's a giant thing. Yeah, things have changed. I do believe, maybe Martin or somebody can tell us what it's like now getting a helicopter. The best thing is to go on somebody else's project who's done that.
Piggyback on it.
Yeah.
Yeah. Carl, any reflections on field work up here?
Well, going back to your first question of what attracts, I think a lot of this allure was things like Jack London and especially Robert Service. I was very impressed with Robert Service writing, and the North meant a lot. So when I went into the Navy, I requested that I wanted to come into the North, and that was, there were some things on East Greenland and West Greenland, but there was also Alaska. So they immediately sent me to the tropics. Then I just knew, now if I were going in the Navy, I'd say, I'd really like to go to the tropics, and I could end up on Svalbard or something. But it's an interesting system. But in terms of planning, even with the money involved, there is a lot of things that just can go wrong. And one of the worst things we had was in the diplomatic area. We were working in Greenland, which is part of Denmark. Got into Thule, the first year they were supporting, because we were just doing reconnaissance and getting out there. But we had an airplane that Bader went out on that was going to replace the C-47 on skis. It's a C-47 or the DC-3, as people know, twin engine workhorse. That on skis is probably the best piece of equipment ever built. And they used those in Greenland, and the Air Force came up with an idea in '52. It's old-fashioned. So we're going to get a new plane. They got the SA-16. It's a boat hull and some floats out on the end, but it had wheels on it like the PBY, but it was all self-contained with 2 engines right over the thing instead of way up like on the PBY. They went out there and they said, this can land anywhere, on snow and ice, on water, on land. So that's what we're going to use. And they took Bader out to this one site we were checking. And I had a bunch of snow tubes. I was calculating WAG and working. So he went out alone just to check this place, and I was going to come back, and we'd both go out. And they got it stuck. And so it was solidly stuck. And we put JADO units on the side of it. They did, that's what I did in the Navy, put JADO units on PBY, so I knew about that. Put these on, and they'd try to get off, and it just wouldn't make it. So then, that's where I found out about air-sea rescue. The air-sea rescue people had a B-17. Those of you older people remember the Flying Fortress, the 4-engine thing. Beautiful aircraft to fly in, very stable. And I've spent almost 2 weeks flying in that thing because we were going out to check on these people who were stuck and drop supplies to them. But the thing about the air-sea rescue is you never, ever want to call them unless you really want them, because they're going to risk their lives to get to you. And I was so impressed with these guys. One day we were going to fly, and it was stormy, and they said the weather was socked in on the ice cap. We got a radio report. They said they had about 500 feet ceiling, but it was solid. And so I figured, well, we're not going to go. This major said, no, we're going. We're going to go on. We'll circle over until we find a hole. And I remember we found an opening. They knew what the ceiling was between the snow surface and the clouds. Mind you, this is 10,000 feet above sea level where the ground is. So he found a hole, and we went down into it and flew between the clouds and the snow deck till we got to them, and then dropped supplies. And the B-17 with the bomb bays open in the front, and then they just dropped things where they wanted. Well, we dropped enough stuff so they could build a little hut there, because they were there for nearly 2 weeks. And finally, they got one of these monster helicopters. There weren't many around, but they brought one up from the States, and it went out and picked up the people. And the airplane was still there, and the idea was we're going to rescue the pilot, and the co-pilot stayed behind, and they threw everything off the aircraft. It was stripped down. I think they even took out pencil sharpeners or ashtrays. It was just stripped. And then they had JADO units on it with that, no load at all. They got it off and brought it back. We said, why not do it with a C-47 and bring them back? Oh no, if the SA-16 can't get off, then a C-47 can't on ski. Well, after it was gone and they had forgotten and their face was saved, we started flying out there with C-47s to do the work, and they built the whole air base by flying stuff in with C-47s. I mean, they built the radar station. But that's this is the frustrating thing you run. They got lots of money, but they're willing to pour it out without any thought, and then you get a place like where Willow, you start calculating what it costs for a rotor blade. 2 different worlds.
Mm-hmm. Yeah. 2 different worlds. Would you both reflect a little bit about how the Geophysical Institute changed in the time you were actively involved in these researches? Because I know, as Carl mentioned, it was a time of growth, and there were geopolitical forces at play there. So how did things play out? And tell us a little bit about the Geophysical Institute that you remember when you first got here and how things changed over time. Carl
has seen a lot more changes than I have. I think I was the last person hired when this building was built. And Keith Mather was the director, and he was hiring people. I think I was about the last. So I really didn't see any of the old university or the old Geophysical Institute when it was down at lower campus and so on, but Carl has. So Carl, is it okay if I ask him?
Yeah, he's fine.
Should I tell Will or what? Well, it's changed so much. I would say when Ruth and I showed up here in 1960, it had changed a lot from 1950. And Rosemary back here could tell you a lot more about this. She was here when Bunnell was president. And the time we came, there were less than 1,000 students. And that was University of Alaska. There were no community colleges, not even in Anchorage. It was all here, and they just passed 1,000 students, probably the second or third year we were here. There were no buildings on the West Ridge at all. And Keith Mather wanted a new building, and the National Science Foundation had money for departmental development. So he never got anywhere within the university wanting it. So what he did was to put trailers up out inside the building. He had one behind the building. They tacked two of them on. And people said, well, nobody knows that you're having trouble, that you got these trailers. So the next time, he put 4 trailers stacked up right out in front of the building, and they stacked up. It looked like a train wreck. And that was one of the arguments to get it. And they finally got NSF to come through. They built this building here, the Geophysical Institute. It was $4 million. And today, you couldn't touch the place for that. But the new building put up, we had, they couldn't do air conditioning because they wanted to save some cash. They also didn't put the top. They didn't count on so many people coming in and each person getting a computer on their desk. See, the Apple computer came out with the first screen, keyboard, and mouse, so people communicated with the computer on their desk. Before that, you'd punch cards and they ran through a mainframe. Now, with each room not only full of people, but each one with a computer that was putting out heat. And in the summer, this place was like a great big tin can with windows cut in it, and the sun was just pounding through it. And people, some nights, or afternoons, they'd let the steno pool people go and just say, take the day off. It was too hot to work in it. So there's air conditioning came. But the real change, though, has been in the university itself has grown from something that was a little academic Siberia with a graduate program attached to it to a real respectable university. This is why it pains me so to see this casual attitude about chopping the budget, because it's been cut so many times. We're starting to really see crippling effects, and those take a long time to recover from.
We'll hand that back over to Will. And before I come out and ask questions, if audience members have questions, I know you're both still doing research. And Will, you were talking about something I didn't even know existed. What's offshore permafrost?
It's got nothing to do with glaciers, but it was quite interesting. It was an multi or interdisciplinary project, and it was to map permafrost and biological conditions on the shelves of Alaska before any offshore oil was produced. It was amazing that there was people worried about that sort of thing in those days. I don't think they do so much now. And it turns out that at times of low sea level, say during the last, up to maybe 30,000 years ago, the shelves of Alaska were exposed, and it was cold, and so permafrost grew. Then the seas came back. They're coming back today. There's a lot of erosion going on in the Arctic, and sea level is rising. And so you have this transient permafrost growing under land conditions. And the trick is to figure out, we can't look everywhere, The trick is, if you want to build a well or a pipeline, what is the stuff like and where is it? And that's what this project was for. And I liked it because with a physics background, you have these physical problems. The seabed temperature now in the Arctic is negative. So you can't melt the stuff unless you've got salt in it. So the question is, how do you get the salt in it and how fast does it go? In particular, how fast does it go? And it's quite irregular. You can start at the West Dock at Prudhoe Bay and go offshore. And well, the first couple of 100 meters are anomalous because the sea ice freezes to the bottom. It's only less than 2 meters deep. And beyond that, there's a perfectly sharp boundary between the ice-bearing permafrost and the ice-free permafrost. And so the question is, why is that? I mean, you can calibrate your thermistors to the 100th of a degree by measuring the break in the temperature as you go through the permafrost boundary. And there were lots of problems like this, and there were people that did a gross mapping with seismic, and there was all kinds of biological stuff. But I think that's what's interesting about this is that it was probably the first serious interdisciplinary study. And we used to sit up in the lab there at Barrow, and the physicists would talk to the biologists. It was terrific. And then we got television. And it died just like that. Nobody talked to anybody. They just sat there in the common room and they watched television. And that happened in perhaps 1 week, was that complete turnover. But it was a very well-run project. Gunter Weller, who used to be here, ran it. I always thought he did a very good job. But it was not just this university, it was many universities were involved.
And Carl, if you take the microphone, I know you have several long-running projects that you're still doing work on. I mean, there's Greenland and there are other studies with volcano, Mount Wrangell and whatnot.
Well, we're doing, the Mount Wrangell study started in '61. It was Terrace Moore, second president here, who really showed me, I was looking for a place where there was no melting, high altitude, no melting, and a big flat area. He said this Wrangell was the place. We started working there. We found that we were interesting thing that the volcano there was interacting with the ice. We've been following that photogrammetrically for over 60 years now. And last September, I was able to take my oldest grandson, or youngest grandson, up with me. He was here just out of the Marines, and so I'd been trying to figure out, can we do that? We managed to fly down there. Chris Larson's plane, he flew us in to Chitna, where we used a turbo otter, went up, did the full set of air photogrammetry with a short focal length because he had a wide angle. It's a totally different thing than what we had been doing. But that one, and in Greenland, we're following up, revisiting points that we did in the 50s. So it's about 60 years later, and when you get to the 10-meter deep, that's the mean annual temperature if there's no melting. And so we're trying to see what changes have happened there. And at high altitude, there's virtually no change. But around the edges, you're seeing. Anyway, that's one advantage of having done something a long time ago. You can go and check it again.
Well, hang on here, and I'm going to circulate in the audience here, and if any of you have questions you'd like to pose, we'll take them. So does anybody have a question to begin with? Okay.
Or if Matthew has got one. Let's see.
Good.
Thank you. I can't hear well enough, so I hope I'm getting this in the right order. In 1958, the Nautilus went underneath the ice sheet of the North Pole in the Pacific to the Nautilus submarine. And I think it was his second attempt to get underneath the ice. And in order to do that, it had to go down the Barrow Trench. And so when I found that out, Google Earth came up with also Google Sea. And if you look on Google Earth, follow the Barrow Trench north, the continental shelf extends far out there. What I noticed was two round holes about 2 kilometers across each. And I wonder if you're familiar with them, are they methane blowouts?
Oh. It's a good question, but we only worked close to shore, within 10 kilometers of shore. And you're talking about something farther out.
Yeah, I don't know about this case, but in the recent issue of Science, I think just the 2nd of June, there's an article about blowouts in the Arctic from Svalbard down toward Norway. There's flat areas there where there are blowouts, and they're about 1 kilometer in size on the ocean bottom. But I don't know anything about what you're talking about.
I would just like to ask both of you, is this working? Okay. Can you give some advice to younger people as to how you remain sort of intellectually active and involved in your chosen field of pursuit at an age when, you know, many people have called it quits? He's calling you old.
Yeah, for sure.
I guess I am old now.
Well, you work half-time for start, and you don't get paid. That's what I do, and I try to keep track of what's going on in the lab, and I'm working on a problem of my very own, how glaciers respond to climate. And so that's one way of doing it. Other people, I think they're the smarter ones, they go off and do something different. And there are some people here who've done that.
Well, I'm still working because I'm so slow. Many of my projects aren't finished. But I think the scientific or the curiosity is a big thing that drives people. And I think this is a driving force for our species, why we move from place to place. Always want to find out what's going on. And I think that's probably the biggest motivation.
Uh-oh.
I'd like to hear from each one of you what your most significant finding was, or maybe your favorite finding. Maybe those are two different things.
I should pass this to Will. I've never done anything significant.
It's a hard act to follow. I think that what I'm most interested in is this surging, this crazy surging, why glaciers do that, and why some do and some don't. And we have a partial answer for that after years of work, and it has to do with water. And the pressure of the water is related to how much stress the ice is under, and so it's, you know, related to the ice, but only indirectly. It's water that causes a lot of sliding, and that stuff that's under all surging glaciers, at least in the lower half, moves. And it's moving now in Black Rapids Glacier, even though it's not surging, it's just slowly. As I mentioned, it's about half the motion. If you went down there today, you'd find about half the motion was sliding. During surging, it's all sliding. How is that?
Okay, so what have you been most wrong about?
That's easy.
Not personal details, I don't want to hear about that. But
Yeah.
What's your biggest, you know,
Well, we thought that one of our glaciers, Variegated Glacier, would surge once melt started. Then you have water pouring into the glacier, so surges should start when melt starts. That was our biggest mistake. They start when melt stops. You can't do better than that, really. We were completely wrong. It may be that some do that, but in Alaska, almost all of them start surging in early winter. You can relate that to the water business, but it's a little indirect.
It's such a broad question. I don't know, I've been wrong on just about everything I've tried, it seems to me. Some things I've gotten right that were fun when they really worked out well. But it's so easy to make mistakes that I don't think anyone should be proud of them.
Well, could you give a real quick, simple explanation of ice streams and how they start and stop and what they do?
Ice streams are, imagine a big blob of ice like West Antarctica. There are several streams of fast-moving ice embedded in this thing that looks like a lake. It's almost as if you had a water lake, and the streams that drain the lake, you could trace them right up to the divide almost. And now change this to ice, and you have the great ice streams of Antarctica. And there are similar streams in Greenland, but they probably have a different mechanism. So there you go, it's complicated. In Greenland, they're probably akin to what happens in valley glaciers. Simple things about water and sliding over a bed. And I guess the Antarctic ones are like that too. They're not completely understood. And it was a big surprise when they were found, that these streams draining what looks like a stagnant lake. And I don't think I can say more unless we get into the highly technical. But it's also a switch between cold and warm bottoms of the glaciers. There's no steady state one temperature probably. And these ice streams come and go, which is another mysterious thing. And they're temporary things, and some of the ice streams you see, and probably you've worked at down there, have actually stopped. They're not ice streams anymore, and you identify them by the crevassing. So it's sort of like surging, they come and they go.
Well, I want to thank our guests tonight, Will Harrison and Carl Benson, for coming here, and thank you for showing up.